What's up, guys? Welcome back to Vanover Customs, and in today's video we're continuing with the big Lion lathe project. It seems like the scraping goes on and on, but that's okay. We're going to be working on getting the gib properly fit and talking about the misalignment of the top slide and how we're going to be addressing that in relation to mainly the nut. I'm going to bring you in closer and we'll jump right in. Now that we're looking at the top slide, it's time to get the gib fit. In the last video, you've seen us scrape the flats and the dovetails, and when we went to fit the gib, it shot right through. That may seem obvious, but with the material we removed both on the flats and the V-ways, caused our top slide to come down about a combined 15 thousandths, which caused our gib to become unusable. Now, there are several methods for correcting this issue, and before we jump in, I want to address those. But unfortunately, when it comes to really good technical scraping content, there's not really a lot of material out there in terms of correcting the geometry. So I want to take some time explaining what we're doing and why we're doing it, so those of you who are following along can understand the direction we're going. The main reason we need to correct the geometry on this top slide is really for the fitment of the nut. Now, if you're doing this at home and you're just doing a new nut or a new gib, it's probably not a big deal, but when you're rebuilding the entire piece of equipment and scraping multiple surfaces, you're really making a lot of changes, and each of those changes affect each other. Now, this nut is going to be highly affected both in the height of the nut, up and down, and side to side, because we've scraped all these surfaces. So we really want to make sure that we're getting a good fitment with the nut. Otherwise, if we're kind of willy-nilly and we go to put this back together, our nut is not going to fit. Now, the good news is there's 3 ways that you can address this issue. The first way that you can address this issue is by shimming behind the gib. This is what most of you guys recommended in the comments. And the best part about this way is it's quick and easy. If you have a machine that's down or worn out, you can easily pull the gib out, shim it quickly, put it back together without doing any heavy repair. But as with most quick and easy fixes, there's always a better way and a downside. The main downside to shimming behind the gib is that in this case, we're trying to correct the alignment with the nut, and that isn't going to help us. It's just going to push the top slide to one side. Ideally, we want to split the difference from left to right so our nut can stay centered. That brings us to the second method. The second method was actually recommended to me by Richard King, and that is turkiting the swivel side of the top slide. Now, the main benefit in that is it's a little bit better repair than turkiting the gib or shimming the gib because it's more permanent. It's on a permanent fixture. Sometimes people quickly shim the gib and the shim falls out, so this method sort of eliminates that downside. However, in this case, it doesn't actually fix our problem of centering the nut because it's just pushing all the air to one side. And also, it means that all the work we did on that swivel side is basically useless, which is why I don't really like that method. Which brings us to the last method, and the method we're going to be choosing for this build. And that method is turkiting the bottom of the top slide flats. Now, to be honest, I probably should have done this from the beginning, but as you're seeing, I'm learning as we go. The reason why this method is the best is because it's returning everything to a factory state. It allows us to solve multiple problems at once, albeit with a little bit more work up front. By going ahead and turkiting the bottom of the top slide, not only is it going to allow us to kind of bring the top slide up, which will bring us closer to the original factory position, it's also going to eliminate the side-to-side issue we're having with the nut because we can actually bring the top slide uniformly, both left and right, back to its original position. Not only will the nut fit properly if we do that correctly, but then we won't have to shim the gib or the swivel side of the top slide. We're over here at the surface plate. We're getting ready to do our turkite. Now, this is the first time I've used turkite, so it's a fun little experiment. I know that other people have recommended using just a general epoxy, and I'm sure it works. But to be honest, I don't want to spend all the time and effort rebuilding this machine and try to save $100 on the epoxy. So we got the right stuff. It's 2 parts. It's pretty expensive. It's like $110 for these 2 little small containers. But we're going to do it the right way. Big shout out to Ron Grundy for pointing me in the direction of the Wisconsin Machine Tool Rebuilders who sells this stuff. It's a little hard to get a hold of, but they were able to ship some to me pretty quickly, so that's really nice. Let's jump in here and get this surface scuffed up so we can get started. As much as it pains me to ruin our already scraped surface, I want to come in here and scuff this up with a 24 grit. Apparently the instructions on this epoxy are pretty particular, and the guy who sold me this said follow them to a T. So we are coming in here and getting this scuffed up so that way we can get ready to apply the epoxy. Once the surface is properly scuffed, you want to come in here and clean it with acetone or lacquer thinner or even isopropyl alcohol. You just want to make sure you get any residue or metal flakes up before we apply that epoxy. We'll get this bad boy flipped over, and then I'll use a lifting magnet to kind of lift it up. I want to get it off the ground. We'll give it one last wipe, and then we'll apply our turkite to the surface plate. It's not strictly necessary to use a surface plate when you're applying this. It just makes a really nice flat surface, and since we're over here anyway, I figured I would use it. Plus, the flatter the surface is when we glue this up, the better it'll be. It'll just mean less scraping or machining when we go to remove the excess. Then we're coming in here and quickly cleaning the backside of the turkite with alcohol. That way we can make sure it's clean and ready to be glued. We're going to get this stuff mixed together over here on a scale. Now I'm sure you could do this by eye, but the directions specifically state weighing each part. I think the most important part about that is just to make sure that there isn't any unhardened material, which can happen if you have unequal parts. I'm mixing this in a figure 8 pattern and folding it back on itself. You want to be careful not to whip this up. It's kind of similar to Bondo. If you whip it around and mix it in properly, you're going to add a lot of air bubbles. Then we're going to go over to the turkite and spread it on the turkite. The spreaders they give you are specifically designed for the turkite epoxy. They have nice big grooves in them, so you can make sure you get a nice even spread. It's kind of similar to what you use if you're using grout or mortar when you're tiling. Using the lifting magnet, we're trying to get this guy dropped down. I made sure to have extra turkite on both sides so that way the alignment isn't super critical. Once we get that squared away, we need to get the correct amount of weight placed on the top of this. The instructions are pretty clear about the specific amount of downward PSI required during clamping. That way it has the correct amount of pressure. If you over pressurize it when you clamp it, you're going to squeeze out too much of the epoxy. And if you under clamp it, well, it's not going to adhere properly. If my memory is correct, I believe they wanted between 5 and 15 PSI of clamping force per inch. So we did the math calculations and I figured out that I needed about 500 pounds of downward pressure on top of this to achieve that. So we stacked up a bunch of random stuff to get to that number. After waiting about 48 hours for the turkite and the epoxy to fully cure, I'm going to get this flipped over and then we'll go around the edge with a knife and trim off the excess. Then with a sanding block, we're going to go around and chamfer all the edges of the turkite. A lot of people recommend against this because you want a nice clean edge that's going to keep the chips out. However, if you have a really sharp corner on the turkite, it's easy to catch and chip out. So I'd rather go ahead and get this chamfered to kind of minimize that, especially since I'm going to take the top slide on and off several times during the scraping process. And also since I'm using extra way wipers, that shouldn't be too big of a deal. With the top slide flipped over in the milling machine, we're going to come in here and machine out these oil grooves and pockets. We're using a chamfer end mill that's carbide. Turkite is pretty free cutting, but because of the nature of its composition, it can dull end mills, so just be aware of that. What I really like about using the chamfering end mill here is it allows us to have a nice clean transition between the cast iron and the turkite, kind of similar to what we were experiencing by sanding it with that sanding block. After using the chamfer mill, we're going to come in here with a regular ball nose end mill and just clean up these oil cavities. This is the spot where the ball oilers deposit oil and then it travels down those longitudinal grooves. We got the oil grooves cut out. Everything looks real nice. We have really good adhesion with the turkite. The only areas that were popping up were the areas in the center that were deeper, so the glue didn't get full penetration, but on the edges, everything is nice and fastened. I just went around with some sandpaper and tried to ease some of these edges just minorly so that we don't catch. Turkite is very strong in compression, but I don't want to try to ding it or bash it any more than I need to. So we're going to be very careful taking it on and off of the actual carriage from this point forward, just because I don't want to come and strike the edge and try to either peel it up or chip it out or anything like that. So we're going to be real careful, but the next step is to get this flipped back over and test fit over on the carriage, and then we will see how much material we'll need to machine off the top before we start scraping. With the top slide mounted to the carriage, it's time to fit the gib and see how we did. Hopefully it doesn't slide all the way through, but I'm sure it won't. And not bad. We have about 2.5 inches sticking out, so that's plenty of meat for us to machine off of the actual top slide. The next step is to do some calculations and figure out how much material we need to remove off the top slide to bring it down so that way we have a good flush mount for the gib. So let me do some calculations and then we'll bring you back over at the milling machine. After doing some calculations, we were able to figure out the amount of material we need to remove off the top slide to bring us back to factory spec. It turns out we're about 15 thousandths-ish oversized from the original factory position, and that should be what we're trying to shoot for, so that way our nut will fit not only side to side, but in the up and down direction without requiring shimming. Now I'm not going to machine off 15 thousandths because that wouldn't leave us any room to do any scraping, so we're going to start by machining off 10 thousandths. And then from there, we're going to scrape in the final amount. Most likely our gib still isn't going to fit perfectly with those numbers because the gib has experience somewhere, but that should put us very close to within the range we need to be. Back over at the bench, let's test fit the gib, see how we're looking now that we've taken off about 10 thousandths. And much better. Looks like we have about 1.5 inches, maybe 1.75 inches remaining. We're going to go ahead and scrape out the rest of that height and fine tune the gib fitment and bring us back down to the place we need to be. Scraping turkite is a thing in itself entirely, but in general it's rather soft and pull scraping tends to work better. Hand scraping is the preferred method for scraping turkite, so we're going to come in here and pull scrape this. Like all the other scraping processes we've been doing, we're going to come in here and do a cross hatch pattern first. Once that's done, we'll do a test print for the first print and kind of make our corrections from there. In a weird way, scraping turkite is easier because it's softer, but in another way, it's a little bit more complex because you have to pull scrape, and it's just a little bit of a weird feeling, but over time, it's something you get used to. When you get close to the edge of turkite, you do need to be careful because if you're too aggressive, you can easily chip out the corner. That's another reason why I think having the edges broken really helps. Let's go ahead and get this top slide over to the surface plate and get this blued up. We'll go ahead and make sure it's blued good, and then we'll test to see how it hinges. We're not exactly 1/3, looks like we're a lot more in the middle. Let's flip it over and see if we can confirm that. And looking at our print here, you can definitely see that we are high in the middle. So we need to just work the middle down and then do another print and go from there. While we have the top slide off, I'm going to take an opportunity to clean up the face that's facing the chuck. This is not critical at all, but it's pretty scored up. Looks like someone ran the chuck a little too close to the top slide. So we're going to bring it over to the K&T mill and use it kind of as a surface grinder. You'd be surprised how well this works. You just get the feed set correctly and we'll clean it up. Once everything's cleaned up, it seems to be nice and smooth. Not only does it look good, but it'll be a nice reference surface in case we need to reference off that edge. At the top slide back over here at the surface plate, and I just want to be honest with you guys, we made a mistake doing the turkite on the last step. Everything was perfect except for the fact that we probably machined off like 2 or 3 thousandths more than we should have. By the time we went to scrape it in, we ended up bringing the level down more, and when we fit the gib, it just wasn't where it needed to be. I could have probably rolled with it. The gib was about 1/4 inch in from the end, but we're really doing this to make sure the gib fitment is correct as well as the nut height. So I decided to re-turkite everything and start over. Now, in doing that, we did not cut the oil grooves because I wanted to make sure everything was scraped and fitting good first, and then we'd come back and do the oil grooves. I also wanted to try a different method for machining down the turkite. So what we did is we have this automotive sandpaper taped to the surface plate, and we use that to uniformly sand down the turkite. It proved to be a little bit more accurate and a little bit more quick. I know that's not ideal for the surface plate, but this is a beater surface plate and I'm not too worried about it. Once we get it in position, we'll level it and have someone come out and go ahead and lap the top. So for now, I'm not too worried about wearing the plate unevenly. I figured out that you got to be a little bit more careful with the turkite just because it is softer. It's a lot easier to overshoot your measurement by taking too much off. So with this method of sanding, it's a little bit less aggressive and we can kind of creep up on our level instead of overshoot it. Now I know that this method of removing material is a little bit unconventional, but trust me, it actually works extremely well. When I machined it and scraped it before, I was hinging decently, but I was high in the middle. And after doing the sanding on both sides, I was actually hinging about 1/3 from the end. So it is a relatively flat method, and it really works well. I've never seen anyone do it, but I would recommend it as long as you're not too worried about unevenly wearing your surface plate. Now that we got everything sanded and it's hinging pretty good, we're going to come back and scrape this. I'm not going to show you too many shots of this just because it is a little bit redundant. So I'll bring you back once we have a decent print and then we'll kind of go from there. Here's a shot of our first print after we cross-hatch both sides. And you can really see the difference. We didn't do any step scraping or anything. This is straight after sanding and then cross-hatching. We have really good coverage and we are really flat. Now we do need to refine this a little bit more, so we're going to come in here and pick off the high spots and then we'll work it a little bit more off camera, but already we're looking real nice and we don't have a ton of work that we need to do to get it where we need to go. And here's a look at our second print. It's a little bit better than our last. We have a little more consistency, but we are losing some of the points. So we're going to come in here and make 5 or 6 more passes and check back in and see how we're looking. Overall, we're looking pretty good. We're just trying to pick off the highs and take these larger points of contact and turn them into a smaller contact area. Overall, we were looking pretty good as we were. We just didn't have the contact points that we really needed. But as far as overall coverage, we were looking good. So just trying to pick off the highs is really going to help bring the entire level down and get us to a spot where we do have more contact. After about 5 or 6 more rounds, this is where we finish out. And I'm really happy with this. I would like a little bit more surface contact, especially on the wider side. However, I realized that the wider side has less downward pressure when we flip this over to do a print, just because it is a wider surface. So that is to be taken into consideration based on our results. But overall, for what we're doing, I think this is going to work great. And because this is turkite, it is going to wear in a lot quicker. And so I think that'll help us bring the level down and get more contact. But overall, we have a very even print, and I'm very happy with it. With everything assembled, you can see that the gib sticks out about 1/8 of an inch, and I'm really happy with that. That gives us plenty of meat to adjust the gib in as the turkite wears. And overall, the height of the top slide ended up being about 2 thousandths higher than the original factory position new, and I'm really happy with that. That allows us a few thousandths to come off during the run-in period and allow us to return back to factory. It's better to have it a little on the higher side than to have it undersized. Otherwise, as it wears, you're going to need to continually machine material off the top of the nut block. Now that we got the top slide worked out and we got the gib fit, it's time to finally move on to scraping and looking at the gib. We got it over here on the surface plate just to see how it's going to hinge, and overall it's looking pretty good. It does seem to be hinging about 1/3 from the end, so it is pretty close, and fortunately there is a fair amount of factory scraping left on the gib, so we're really not going to do a lot of work to it. We're going to come on here and do a nice crosshatch pattern and blue it up and see where we're at, but for the most part we're just going to add some spots for oil retention. We went ahead and got this blued and test fit off camera, and this is the results of our bluing. As you can see, we are looking really good. Again, keep in mind with a gib, it's a lot more likely to get a smear. We are a little bit higher in the center, but that's not a major deal. That's really confirmed by what we've seen with the hinging. We're gonna come in here and address some spots in the middle just briefly, but for the most part, we're looking really good. We're extremely close. I'm not gonna spend a lot of time on this gib, and frankly, it doesn't have a lot of wear. So I'll go ahead and get this scraped off camera, and then we'll bring you back when it's all set. Now that we got the gib fitted, scraped, we have it hinging good and spotting good, it's installed. The last and most important step is to make sure that the cross slide functions properly. It's one thing to make sure it hinges good and blues good. It's another thing entirely if you put it in here and it binds, right? Obviously, if you run it loose, you can prevent that, but we want to be able to run this as tight as we can without it binding. And so when I first installed this and I operated this, we were pretty good, but we had a tight spot right at the back in here, which makes sense because that's the least worn area typically. Now, even though I have scraped this backside, I went ahead and step scraped that area of the dovetail just slightly, and it's operating much, much better. I went in there with a pry bar and an indicator and tried to jack up on the top slide off of the base, and I'm getting anywhere between a 0.5 thousandths and 1 thousandths movement. And again, we're not operating it with a screw, which we're going to have more leverage, so I can tighten it a little bit more and I could run it a little bit looser. But just from a preliminary look, if I put an indicator on it and I slide this back and get a pry bar under here, I can move this up about the same amount that I can over here, right? If it was real loose in the middle, like being super worn, then it would move a ton here, and then when you got back to the end, it would be super tight and wouldn't move anything. And I just kind of confirmed that by going over to the American lathe, which I know is worn out, and lo and behold, you push it all the way back, you get a pry bar under there, tight as can be, right? You run it to the middle, you got 2, 3, 4 thousandths of upward movement. So if we can get on here and make sure that with a pry bar we're getting the same amount of movement there that we are here, that means that this fits properly and is going to slide nice and easy. It's not going to get tight at the end like pretty much every single lathe I've ever used, and it's going to be able to hold a really nice tolerance as we're sliding it And also, during deep boring, if this is super loose, it's gonna chatter like crazy. So we wanna be able to run it as tight as we can with it still being able to move freely. So I think we did that, and I'm very happy with that. Overall, I'm glad that this scraping is finally coming to an end. We do need to address the bottoms, but that'll be in the next video. If you guys have any questions, post them down below, and we'll see you in the next one.